I'm always confused when I see some of the students don't understand the resonance. I will tell you why you don't understand the resonance. Because you didn't try to make the Lewis diagram correctly with your hand. If you try to make the Lewis diagram, you will see that there is an option it to make it correct from the octet rule, and everything is correct. Sometimes you find that there is more. Option one is possible, option two is possible, maybe option three. So if there is more than one possible option and all of them are correct, this is what's known as resonance. So the structure one is okay, structure two is okay, structure three is okay, and all of them is following the octet rule. Some of the students think that the structure keeps resonating or moving between the three different structures. Who say that A is valid, B is valid, and C is valid. So it's either this one or move to this one or this one. This is not correct. The valid structure or the valid resonating structure is actually hybrid of these ones. So it's like a mixture. Like if you have blue or red, the compound does not resonate between the blue or red. It's actually a mixture of them. So when you put the blue and red as a hybrid and make a purple color, this is a valid resonating structure. In the periodic tables, the nitrogen comes from the fifth group and oxygen is from the sixth group. So this means that the nitrogen has 5 valency electrons. Let's draw them with the red color to be identified as the valence electrons or the outermost electrons of the nitrogen, while the oxygen is coming from the sixth group, because it's coming from group number 6. That's why it will be having 6 valency electrons, and there is 3 of them. Because there are 3 oxygen atoms, so there are 18, 3 multiplied by 6 valence electrons. Don't forget that this is the nitrate compound contains, or the nitrate ion contains 1 extra negative electron. So I will put this one here to make a total of 24 electrons. If you are feeling very confused of what I am doing now, so please go back to the video of the Lewis diagrams. You are not supposed to come here yet. 5 plus 18 plus 1 is 24 electrons. Valence electrons should be distributed between the atoms to make the Lewis diagram. Well, which one do you think will put in the middle, the nitrogen or the oxygen? Of course, I'm going to put the nitrogen with its 5 electrons in the middle. It doesn't make sense to put 3 atoms of the oxygen in the middle. So 1, 2, 3, 4, 5. And you need to make at least one bond with each oxygen atom. So I will use one of these electrons to make a bond of this oxygen, and I will use one electron to make bond with this oxygen and one more bond. Don't forget that you have one extra electron here. So this is coming from the negative. So I have drawn all the 5 electrons, the nitrogen. I used only 3 of them to make bonds, while the oxygen, every one of them has 6. I used 1 electron only to make a bond with each nitrogen. So that's always the start of the Lewis diagram. 1 electron from here, 1 from here, and 1 from here. Because everyone has 6, so there is 5 more remaining. 5 more extra electrons. And 1, 2, 3, 4, 5. Of course, this is not making an octet. If you counted the electrons around the nitrogen now, you will see it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this means that you need to remove 1 electron from here and make an extra bond with this oxygen. For every covalent bond you need to make again, you need to put 1 electron from every side. So use the electrons that are not used. So you made a double bond with this oxygen, and this oxygen now has an octet. This oxygen now doesn't have an octet. 1, 2, 3, 4, 5, 6, 7 only. So use 1 extra electron from here to make a bond with this oxygen. So 1, 2, 3, 4, 5, 6, 7, 8. Let's look at the electrons of the oxygen. This is octet now, 2, 4, and then 6 and 8. While the other one has 2, 4, 6, and 8. So both of them are octet. Now what about the nitrogen atom? The nitrogen atom contains 2, 4, 5, 6 only. How can I make? No, there is still more. 2, 4, 5, 6, 7, 8. So this means that I don't need to make any more double bonds. I must take this electron out. Because if you try to make any more double bonds, like you use this one to make a double bonds, it will fail. Oxygen now is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So you have to add the H1 to it, and that's it. So what is the structure that you have made here? I have made a nitrogen atom in the middle, and it has a double bond with this oxygen, and double bond with this oxygen, and single bond with this oxygen. So this one has 8 electrons now as a total octet is fulfilled for this oxygen and fulfilled for this oxygen. I can hear you asking, why did I choose this electron? Why did I choose this atom in order to make the double bond with it? Why I didn't choose this one or this one? So actually that's a correct question. So you are forced to try to make two other shapes. This is the first one of them. You made the double bond with this and double bond with this, and this became the single bond. So this time that was the oxygen with a single bond. Now this is the oxygen with a single bond. What is the third structure? This one is the third structure. So if you are confused on which one is the correct one, so that's the resonance. So simply resonance is, resonance in chemistry simply refer to the phenomena where a molecule or an ion can be represented by two or more valid Lewis structures. We call these structures resonance forms. These resonance forms only differ in the arrangement of electrons. It's good that you understand now, but still we have one more short, very tiny question to ask. In the resonance diagram, which is actually the correct diagram of the three that we draw. The actual structure is actually a weighted average, so a resonance hybrid of these forms. When you try to draw the nitrate to explain the idea of resonance, you have to make the electrons in this way. Just draw the dashed line. This will explain to the examiner or the chemist trying to understand that actually this bond might be there or might not be there. So the double bond is actually resonating, making a hybrid structure between these different structures. So it's not any one of the three, it's actually all of them. Another example is oxygen in the form of ozone gas, made from 3 oxygen atoms. 3 into 6 valence electrons is 18 electron. So the oxygen is bonded to every other oxygen with one single bond only. So out of 18 electrons, we have finished only 1, 2, 3, 4. So this one has 1 and 5 more not bonded. And this one has 2 and 4 more not bonded, and this one has 1 and 5 more not bonded. So the best way for this to make the Lewis diagram, because this one is 1, 2, 3, 4, 5, 6, 7, 8, is to take 2 electrons and put them on one side. So let's have a look. This want to be octet 1, 2, 3, 4, 5, 6, 7, 8. So we have to take one of the electrons from here and make a double bond here. So let's have a look. This will be an electron, and this other electron will make a double bond like that. So take this electron from here and make double bond, and take this electron from here and make it as single bond like that. So this one will be here and make it as single bond. So in this case, this oxygen will be 1, 2, 3, 4, 5, 6, 7, 8, and this is 1, 2, 3, 4, 5, 6, 7, 8. So we have a double bond with that one and a single bond with this one. But why is this one making the double bond and single bond and not the other one? That's why the option can move to the other bond. So it will be a double bond here. Oxygen is 4 electrons here, so it's 8. And this one still has lone pair and one single bond. So 1, 2, 3, 4, 5, 6, 7, 8. And this one will be with the single bond, so it has 6 electrons. So I have two options and I'm looking at them So this is the resonance structures. If you want to make the hybrid form, it will look like that: one oxygen atom and this single and this single, and this one has the dashed line because it can be here or it can be here. That was all for the basis of resonance, and you can see more videos if you want to see how the resonance can be formed in other structures, ions or molecules.